Dyson
Dyson
sphere.
sphere.
A Dyson sphere is a hypothetical megastructure that encompasses a star and captures a large percentage of its solar power output. The concept is a thought experiment that attempts to imagine how a spacefaring civilization would meet its energy requirements once those requirements exceed what can be generated from the home planet's resources alone. Because only a tiny fraction of a star's energy emissions reaches the surface of any orbiting planet, building structures encircling a star would enable a civilization to harvest far more energy. The first modern imagining of such a structure was by Olaf Stapledon in his science fiction novel Star Maker, 1937. The concept was later explored by the physicist Freeman Dyson in his 1960 paper, Search for Artificial Stellar Sources of Infrared Radiation. Dyson speculated that such structures would be the logical consequence of the escalating energy needs of a technological civilization and would be a necessity for its long-term survival. A signature of such spheres detected in astronomical searches could be an indicator of extraterrestrial life. Since Dyson's paper, many variant designs involving an artificial structure or series of structures to encompass a star have been proposed in exploratory engineering or described in science fiction, often under the name Dyson sphere. Fictional depictions often describe a solid shell of matter enclosing a star, an arrangement considered by Dyson himself to be impossible. Origins. See also, energy development. Inspired by the 1937 science fiction novel Star Maker by Olaf Stapledon. For the physicist and mathematician Freeman Dyson was the first to formalize the concept of what became known as the Dyson sphere, in his 1960 science paper Search for Artificial Stellar Sources of Infrared Radiation. Dyson theorized that as the energy requirements of an advanced technological civilization increased, there would come a time when it would need to systematically harvest the energy from its local star on a large scale. He speculated that this could be done via a system of structures orbiting the star, designed to intercept and collect its energy. He argued that as the structure would result in the large-scale conversion of starlight into far-infrared radiation, an Earth-based search for sources of infrared radiation could identify stars supporting intelligent life. Dyson did not detail how such a system could be constructed, simply referring to it in the paper as a shell or biosphere. He later clarified that he did not have in mind a solid structure, saying a solid shell or ring surrounding a star is mechanically impossible. The form of biosphere, which I envisaged, consists of a loose collection or swarm of objects traveling on independent orbits around the star. Such a concept has often been referred to as a Dyson swarm. However, in 2013, Dyson said that he had come to regret that the concept had been named after him. Search for megastructures. Dyson-style energy collectors around a distant star would absorb and re-radiate energy from the star. The wavelengths of such re-radiated energy may be atypical for the star's spectral type, due to the presence of heavy elements not naturally occurring within the star. If the percentage of such atypical wavelengths were to be significant, an alien megastructure could be detected at interstellar distances. This could indicate the presence of what has been called a Type II Kardashev civilization. SETI has looked for such infrared heavy spectra from solar analogs, as has Fermilab, and Fermilab discovered 17 potential ambiguous candidates, of which 4 were in 2006 called amusing but still questionable, and later searches also resulted in several candidates, all of which remain unconfirmed. On October 14, 2015, Planet Hunter's citizen scientists discovered unusual light fluctuations of the star KIC 846-2852, raising press speculation that a Dyson sphere may have been discovered. However, subsequent analysis showed that the results were consistent with the presence of dust. 1718. A further campaign found evidence of 7 possible candidates for Dyson spheres. However, further investigation is required. Feasibility and science-based speculation. Although Dyson sphere systems are theoretically possible, building a stable megastructure around the Sun is currently far beyond humanity's engineering capacity. The number of craft required to obtain, transmit, and maintain a complete Dyson sphere exceeds present-day industrial capabilities. George Dvorsky has advocated the use of self-replicating robots to overcome this limitation in the relatively near term. Some have suggested that Dyson sphere habitats could be built around white dwarfs and even pulsars. Stellar engines are hypothetical megastructures whose purpose is to extract useful energy from a star, sometimes for specific purposes. For example, Matryoshka brains have been proposed to extract energy for computation, while Shkadov thrusters would extract energy for propulsion. Some proposed stellar engine designs are based on the Dyson sphere. Fictional accounts. A precursor to the concept of Dyson spheres was featured in the 1937 novel Star Maker by Olaf Stapledon, one in which he described every solar system, surrounded by a gauze of light traps, which focused the escaping solar energy for intelligent use. Dyson got his inspiration from this book and suggested that Stapledon sphere would be a more apt name for the concept. Fictional Dyson spheres are typically solid structures forming a continuous shell around the star in question. Although Dyson himself considered that prospect to be mechanically implausible, they are sometimes used as the type of plot device known as a big dumb object. Dyson spheres appear as a background element in many works of fiction, including the 1964 novel The Wanderer by Fritz Leiber, where aliens enclose multiple stars in this way. Dyson spheres are depicted in the 1975 to 1983 book series Saga of Cuckoo by Frederick Pohl and Jack Williamson, and one functions as the setting of Bob Shaw's 1975 novel Orbitsville, and its sequels in the 1992 episode Relics of the TV show Star Trek. The Next Generation, the USS Enterprise finds itself trapped in an abandoned Dyson sphere. In a 2011 interview, Dyson said that he enjoyed the episode, although he considered the sphere depicted to be nonsense. Michael Jan Friedman, who wrote the novelization, observed that in the TV episode itself the Dyson sphere was effectively a MacGuffin, with just nothing about it in the story, and decided to flesh out the plot element in his novelization. Other science fiction story examples include Tony Rothman's The World is Round, Somto Sukarical's Inquisitor series, Timothy Zahn's Spinneret, James White's Federation World, Stephen Baxter's The Time Ships, and Peter F. Hamilton's Pandora's Star. Variations on the Dyson sphere concept include a single circular band in Larry Niven's 1970 novel Ringworld, a half sphere in the 2012 novel Bowl of Heaven by Gregory Benford and Niven, and nested spheres, also known as a Matryoshka brain, in Colin Capp's 1980s Cage World series and Brian Stableford's 1979 to 1990 Asgard trilogy. Stableford himself observed that Dyson spheres are usually MacGuffins or largely deep in the backgrounds of stories, giving as examples Fritz Leiber's The Wanderer and Linda Nagata's Deception Well, whereas stories involving space exploration tend to employ the variants like Niven's Ringworld. He gives two reasons for this. Firstly, that Dyson spheres are simply too big to address, which Friedman also alluded to when pointing out that the reason that his novelization of Relics did not go further into the sphere was that it was only 400 pages and he had just shy of 4 weeks to write it. And secondly, that, especially for hard science fiction, Dyson spheres have certain engineering problems that complicate stories, in particular, since gravitational attraction is in equilibrium inside such a sphere, per the shell theorem. Other means such as rotating the sphere have to be employed in order to keep things attached to the interior surface, which then leads to the problem of a gravity gradient that goes to zero at the rotational poles. Authors address this with various modifications of the idea, such as the aforementioned Cage World nesting, Dan Alderson's double sphere idea, and Niven's reduced ring world, discussed in Bigger Than Worlds.